Welcome, everybody. I would like to um, present the installation and the operation manual, video manual for the LMS 5 software. In the delivery package of the LMS, there is the USB stick. On the USB stick, there is just one file, the LMS install exe. When you double click on this file, you'll be asked to allow for the administration rights, and then when you agree to it, you will be guided through the setup. The version described in this manual is version LMS 1.3. So after answering simple questions about creating a desktop shortcut and about the usernames, it's enough to press and install. Then in the next window, the USB drivers will be installed. So it's enough to press extract here and proceed, accept the agreement for the drivers, and then finish it, and finish the completing the setup. The installation is now available in the menu under the name of LMS. So when we enter the LMS 5 application, we are welcomed by two parts by a window consisting of two panes, of two panels. One panel with buttons with laser text, and the second auxiliary panel to the right with auxiliary information. First, we'll start with the auxiliary panel because in this panel we can connect to a laser detector. The detector I have prepared and switching on the detector and the laser is done by pressing the only button, power on button, available on the detectors by a longer time than 3 seconds when the LED starts to turns blue from the initial white. But then we are prepared to connect to this detector from the software. This might take a while depending on the computer and on the Windows. After successful connection, we will receive, some data will be read from the detector. Going from the top, we will have information about the quality of the detected beam. The quality means basically informs us about any dirt in the optical path. So if the optical components, so optical outputs of the laser and the optical inputs of the laser are clean enough. In normal conditions, the quality of the signal should be above 90%. So if it falls below 90%, it means that the optics needs to be cleaned. Then we have the chart showing the position of the beam, a detected position of the beam. The chart can be magnified to the full screen. Here we can also zoom the chart with a mouse button, with left mouse button, and then we can zoom and unzoom the chart to see more details where the beam is. This information is also given in the bottom, in the top right edge, in the numerical form. And if we contract it back, then this same information is given here with X and Y in numerical form. Then below, we have an information about the state of the particular detector that we are connected to, the battery, the signal strength, the battery indicator we have together with graphical form, and we have a battery indicator in the numerical with the numerical values. Then we have a list going down, or below this information we have a list of detectors seen in Windows or registered in Windows. In my case, it's 3 different detectors with different serial numbers, so I have to know which detector I'm connecting to. This serial number is available, is written on the detector itself. We can connect with this button or disconnect with the detector with this unplugging button and reconnect to any other. And we can research the available Bluetooth devices with this magnifying glass. In the main part of the window, they are described, there are 4 possible measurements available: axial straightness, squareness, and life measurement. So step by step, let's try to find out what's inside, what are the options in all those measurements. First measurement, the axial one. When we enter this measurement, there are available 2 buttons: one for starting the measurement, second one for opening or reopening the measurement previously performed. In case of starting the measurement, we are directed to the configuration window, where we can choose between the measurement of automatic and manual tape, and we can choose if we can configure the measurement, setting the start point, the end point, the number of stages, the name of the axis of the spindle, and all the data necessary to generate the G code, because here is when you press the button with G and with the circle, you will a GForm generator will be opened with possibilities of generating a Siemens or Fano compatible codes that you can save and then upload to a machine. More details about the configuration, about the meaning of each of the buttons are available in other video tutorials describing the axial measurement. Then, after entering going forward, we are directed to the measurement screen. In the measurement screen, it's a bit more complex with a few information, a few additional panels. Those panels are currently empty because we are prepared for measurement. When we start the measurement, the data here, the panels will be filled with data. Also, we can fill them with data by opening the previous measurements. For example, such measurement like here. So then we can see the measured axial data. So the position of the detector against the center of rotation of the spindle, so the position of tool, because the detector is mimicking in this configuration in tool and is positioned in a tool holder. So we can see the linearity of changes of this tool against the spindle, against the center of rotation of spindle in single direction, in 2 directions. We can also see the vibrations of the spindle with in the axial chart. This chart can be zoomed and unzoomed as well to see the vibrations in greater or more details. We can also here clear some charts or disable their display by pressing these checkboxes or by pressing the dustbins on the right of the names and of measure 1, 2, 3, and 4. I did. We can also check the data in the numerical form as a table with the errors calculated here in the tool axis 1 and tool axis 2 columns. As well, we have a circular deviation. The circular deviation is the maximum error for the axial chart. The measurements can be saved but also a report can be generated where we can choose the axis which was measured. We can put here the machine operator, the machine which was measured, the serial number of the machine, and also some comment. All this will be added. All those informations will be added to a report, to an extensive report, where the data visible on the particular charts are then placed can be printed to a PDF or printed to some printer, sent to some printer. Also, there is a possibility to here for configuration. The configuration has basically two fields. So this is a help showing us where is X and where is Y. But this is the same marking that you can find on the detector itself and on the display of the detector, because X and Y on the display is the same X and Y that is shown here on in this window. But what is important in the settings, relation settings, is the relation of the data, because the detector doesn't need to be horizontal and vertical position. The detector can be against also set against the gravity, because in some machines the tool turret is rotated at an angle, but it can be also manually rotated at a certain angle. In case of the method choice, it's the statistics for the tool trajectory in X and Y. So we can choose, for example, least square method here, and then the value, the tool trajectory will be modified because the trend will be subtracted. We can modify here also choose if zero, if the first position is zero, or so this is so-called relative, or if we then we have to do a raw data, or if we have a real value of the tool trajectory, and then we also can read some errors. Against more details about it in the tutorial for axial measurement. About the straightness option, this option is a bit simpler, so it has a simpler configuration, because while in the axial option the detector is moving along the laser line, but the laser is rotating. In this option, the detector is moving along the laser line, but the laser is stationary, so the laser is not rotating, so we don't need to configure rotating of the laser. We can choose the automatic and manual method of this measurement. Again, more details in the tutorial for straightness measurement. If we can also generate, depending on our settings, we can also generate the G-code file, which we can save and then upload to a machine to force the machine to move in an appropriate way. The measurements of the data. So when we get to the measurement window, will also be filled with content when we proceed with the measurement, but we also can open the measurements from the previously saved one. For example, we can open such a measurement. This shows two trends in X and Y. Those trends can be, so we can see the linearity because of the trends. This also delivers some information in case of some measurements of the lathes or milling machines if we perform, but we can check only the linearity by entering the configuration and choosing the statistic method. So depending on the statistic method, we can get more information about the real linearity of the axis, not only about the trend we have. In case of squareness measurement, of squareness option, this option is a bit different, because in this option we don't move the laser. We perform no measurement, so there is no configuration possible, because in fact the squareness measurement is the option that where we only a statistical option, where we combine two measurements of straightness. So here there are two select buttons. Those two select buttons. With those two select buttons, we have to open the two straightness measurements. Straightness performed along the laser beam and along the rotation axis of the laser, and perpendicular in the perpendicular direction to this axis. So I have just to prepare measurements for vertical and horizontal case of the machine. And this option only calculates the squareness error of the machine. So here is it's not, and we can only generate a report. So there is nothing more. There is nothing more here. The last option is as simple as the previous one. So this option is used for live measurement, where we can either use it for straightness measurement or for axial measurement, but this option is used for live measurement. So to simplify the setting of the machine, when somebody's when the user wants to set it, for example, mechanically, so we can at certain points clear the values of X and Y, and then we can move the machine to another point, or we can rotate the machine, so we can make it relative to circle position, and we can rotate the machine and rotate the spindle naturally and find the current position of the circle. Then we can move the machine to another position and then rotate it again, or make some program or hardware alterations of the machine and check if this changes the center of rotation or whatever are we measuring. So again, please go to open the tutorial for this kind of measurements, for this type of live measurements, to get more details. The last option we have in the software is the configuration. The configuration consists of five parts. In the first part, we have a choice of the language. So the number of languages in version 1.3 is the English, Deutsch, and Polski, so English, German, and Polish. In case of the second part of the settings, we can choose the units of the distance, deviation of the distance, the angle, angle errors, and the feed rate. Then we have the logo, which is very limited in size, so it has to be precisely 485 by 163 pixels. But when the logo is chosen, then this logo will appear instead of LaserText logo on all the reports. In case of I, we've got here the firmware version for the detector and for the laser if it is connected. So the user normally do not need to connect the lasers, so just the detector version is connected here. And the last thing, the average interval standard setting should be 0.01 second. Yet for a very calm environment, 0 seconds can be used. For a very noisy environment, in case of vibrations, 1 second is advised. Those are all the options of the LMS5 software version 1.3. In more details about the measurement in appropriate tutorials. Thank you for your attention.